Okay, so standard form. So I can explain it to you. So if we take the number 200, now 200 is 2 times 100. Seems to make sense to me. And I know that 100 is 10 squared because it's 10 times 10. So that would be the same as 2 times 10 squared. Now that is 200 in standard form. Okay. I've gone a long-winded way about doing it, but this is just to show you why 200 is 2 times 10 to the power of 2. Okay. So standard form is always going to be something always times 10 to the power of something. Okay, and this something could be a plus or a minus power. Okay, the number itself can only contain one digit. Okay, that's the rule. Okay, it could be 2.6179. Okay, because 2 is a single digit. Okay, we can't have 12 or 30 or 57. It must be one digit. It can have decimal numbers after it, but it must only be one digit. Okay, so instead of going through this palaver here, okay, if I take 4,000 and I want to change that to standard form, it's really as easy as this. Okay, now the only digit of any value here is the 4. It's the most powerful number, so it's going to be 4 times 10. Okay, and that's the bit that people forget. 4 times 10, and all it is the number of times the decimal point has moved from the back of the number to make that 4. Okay, so it's moved once, twice, 3 times. So 4,000 is the same as 4 times 10 to the power of 3. Okay, and we really don't care about whatever the number is. If we've got 316927 and they say change it to standard form, we always go to the most powerful number, and we can only have one digit, so our decimal point is going to go in there to become 3.16927. So it's going to be 3.16927 times 10 to the power of 1, 2, 3, 4, 5. Job done. Okay. Equally, if we've got a number, let's say 2.1362 times 10 to the power of 3, and they say what's that as a inverted commas real number, they want to know what was the number before we changed it to standard form. So the decimal point is just going to go the other way, 3 times the other way. So it's going to go 1, 2, 3. So it's going to go between the 6 and the 2. So we get 2, 1, 3, 6, decimal point, and 2. It is that simple, okay? So the power just tells you how many times the decimal point has moved. Because if you multiply anything by 10, the decimal point will move. Okay, if you divide something by 10, the decimal point is moving. So 20 divided by 10, you know, is 2, because the decimal point moves once, because we've got 1/10 here. Okay, that's why it works. Okay. So where people come adrift is when they see this sort of thing. So let's say we've got 3 times 10 to the power of 4 multiplied by 2 times 10 to the power of 7. Oh. See, I told you, people forget to write the 10. 10 to the power of 7. Right? Now sometimes as well, you might see it in brackets, like this, and you might see it in brackets without the time sign. It still means the same thing. Okay? What you do is you multiply like with like. So we just do the numbers first. So 3 times 2 is 6. Now we know our answer is going to be in standard form, so it's going to be times 10. Now 10 to the power of 4 times 10 to the power of 7. So if you've seen my indices video, or the one on the side, you'll know that if we multiply, we add the powers. So 10 to the power of 4 times 10 to the power of 7, 4 plus 7 is 11. So our answer is 6 times 10 to the 11. Okay. Sometimes they get a bit tricksy and they might say 3 times 10 to the power of 4 squared, and people panic. Okay, so it's knowing what you're looking at. If they say it's being squared, well, anything squared is itself times itself. So that would be 3 times 10 to the power of 4 times 3 times 10 to the power of 4. So once you've done that, it's really easy. Like with like, 3 times 3 is 9. The answer is going to be in standard form, so it's times 10. 10 to the power of 4 times 10 to the power of 4. 4 plus 4 is 8. So our answer is 9 times 10 to the power of 8. Okay, so don't be put off by just one index or one standard form number being squared. Okay, so let's say we've got 5 times 10 to the power of 3 times 7 times 10 to the power of 4. Okay, so we know the easy bit, like with like. So 5 7s, 35 times 10, 10 to the power of 3 times 10 to the power of 4. 3 plus 4 is 7. Okay, now this is right, but it can be righter. Remember I said you can only have one digit. Here we have 2. So the decimal point is going to have to move once more to give us 3.5. So we get 3.5 times 10. Now because the decimal point has had to move once more, that means that the 7 goes up 1 and becomes 8. Okay, because we've moved the decimal point once more, so we have to show that by raising the power by 1. Okay, so let's give you another one. So let's say we've got 4 times 10 to the power of 6 times 6 times 10 to the power of 3. So again, like with like, 6 fours, 24 times 10. Now we've got 6 plus 3 is 9, but we've got 2 digits, so that needs to move once more, which means the 9 goes up 1. We add 1 to the 9, so we get 10. So we get 2.4 multiplied by 10 to the power of 10. So this is right, this is righter. Okay, this is why I don't teach English. Okay, so this is nice and simple. So let's say we've got 6 times 10 to the power of 7 divided by 3 times 10 to the power of 4. Okay, you do exactly the same. You divide like with like. So 6 divided by 3, this can cancel to give us 2. And it's standard form, so it's going to be times 10. So what we've got here is 10 to the power of 7 divided by 10 to the power of 4. So remember, if we're dividing, we subtract the powers. So 7 minus 4 gives us 3. Job done. Okay, so if we've got 8 times 10 to the power of 6 over 2 times 10 to the power of 3. Remember, like with like. So 2 goes into 8 4 times, so I know it's going to be 4 times 10, and 6, take away 3, is 3. Okay. So, now, if we have, the reason that we use standard form is because it helps us calculate very, very big numbers and very, very small numbers. Now, if I've got a number, let's say I've got 0.00013, okay, and they say that, write that in standard form. Okay, so we go along our numbers, and it's only when we get to the 1 that we hit a number of value. Okay, and remember, we can only have one number, one digit. So instead of 13, it's going to be 1.3 times 10, always times 10, so it's going to be 1.3. So now we've got to do, remember, the number of times the decimal point has moved. So it's moving once, twice, 3 times, 4 times. Okay, so our power is 4. But the decimal point is moved in the other direction, so it becomes minus 4. Okay, so the way to remember it is, if the power is positive, it's a big number. If the power is negative, it's a dinky number. Okay, it's just a very small number. So if I've got 0.002617 and I change that to standard form, well, there's my first number of any note, so the decimal point is going to have to go there. So that will be 2.617 times 10. That's a very small number, so it's going to be a minus power 1, 2, 3. So it's going to be to the power of minus 3. Okay. Now I show you this because it comes up in what we've just done previously. Okay. So positive powers, large numbers. Negative powers, very small numbers. Okay. So let's say we've got 3 times 10 to the power of 6 times 2 times 10 to the power of minus 3. Okay, again people run and panic, they see a minus and they freak. We're multiplying, so we go like with like. So 3 2s are 6 times 10. Now we know we add these powers, so I'm going to put in a plus here. So what we've got is 6 plus minus 3. Okay, 6 plus minus 3. Now the plus and the minus can touch, so they're going to react on one another. So a positive and a negative gives us a negative. Remember, different signs always negative, same signs always positive. So the plus and the minus will give us a minus. So now I just read 6 minus 3 gives me 3. Okay. So let's give you another one. So let's say we've got 4 times 10 to the power of 5 times 3 times 10 to the power of minus 3. So we multiply like with like. So 4 3s 12 times 10. Now we've got 10 to the power of 5 times 10 to the power of minus 3. So we're going to add the powers. So I put in the plus there. So 5 plus minus 3. A plus and a minus is a minus. So 5 minus 3 gives me 2. Okay? And remember, this is right, but it can be righter because I've got 2 digits. So this needs to be 1.2 because the decimal point needs to move once more, times 10, and because we've moved the decimal point once more, the 2 becomes a 3. Okay. Now if we look at division, and this is where signs kick in. So let's say we've got 6 times 10 to the power of 7 divided by 3 times 10 to the power of minus 4. So 3 and 6 will cancel. Okay, so I get 2 times 10. Now what I've got is 10 to the power of 7 divided by 10 to the power of minus 4. Now if it helps you, write it out longhand like this. So it's 10 to the power of 7 divided by 10 to the power of minus 4. Now because we're dividing, we're going to subtract. Okay, so what we've got is 7 minus 4. Remember, different signs, always negative. Same signs, always positive. So 2 minuses make a plus. So now I go across the top. So 7 plus 4 is 11. Okay, now we know this is a very big number because it's a positive power and there's 10 multiplying by itself 11 times. Well, that would make sense because this is a very tiny number, yeah, because we've got 10 to the minus 4, so this is a very tiny number. So I would expect this tiny number to go into this number a lot of times. Okay, so we'll do one more. So let's say we've got 8 times 10 to the power of 6 divided by 2 times 10 to the power of minus 4. So like with like, so 2's work well for me. So I get 4 times 10. Now I've got 10 to the power of 6 divided by 10 to the power of minus 4. So 10 to the power of 6 divided by 10 to the power of minus 4. Because I'm dividing, I take away. So I've got 6 minus 4. So 2 minuses give me a plus. So 6 plus 4 gives me 10. So that's my final answer. Okay. So again, I hope this has helped a little bit. I've tried to break it down and do a few so that you can get an idea. Again, if you've got problems, do come online, come and question me about it, and I'll take you through it again. But go back to the assignment, give it a shot, and I'm sure you'll be fine. Okay? Good luck.